going to do 7.5. And 7.5 is solving exponential and log equations. I want to remind you, and we've talked about this before, that exponential and log are inverses of each other. So in order to solve something that is in exponential form, meaning your x is in the exponent, you have to turn it into log. In order to solve something that's in log form, you have to turn it into exponential. One solves for the other one, okay? So I want to start off the very first section. We're going to start off really easy. Example number 1. In the very first section from 8 through 14. When you are solving, I am going to ask that you get a common base. Then you are going to set exponents equal. So, for example, let's say I have, how about 4 to the 3x equals 64. This is your first few problems. You're able to get the same base. So 64 is actually 4 to the 3rd power. And this is 4 to the 3x. If you are able to get the same base and make a one-to-one function, that's what you should do. So then we are going to set our exponents equal to each other. So 3x equals 3. Divide both sides by 3, and x equals 1. Okay? This is similar to what we've been doing, right? Let's do one more similar, but a little bit tougher. Hold on. How about if we do something like 3 try it again. 3 to the x plus 4 is equal to 27 to the 3x. All right. So is it possible to get the same base on both of these? Yes. 3, we can get a base of 3. So this one's going to stay 3 to the x plus 4. Over here, 27 is 3 to the 3rd power. And then we still have our 3x there. So now this is a one-to-one function, and we can set our exponents equal. So I have x plus 4 equals 9x. Subtract my x to the other side. I get 4 equals 8x, and divide both sides by 8. And x equals 4 over 8, or 1/2. Questions on these first couple? This is similar to what we've been doing for like the last week or so. Okay, so let's get into the new stuff then. Example number 2. This is for problems 16 through 22. For 16 through 22, let's say I have, let's go with 9 to the y minus 2 equals, let's go 11. 11 sounds good. I wanted to pick something that you could see. There's no way that these bases are going to become the same, right? 11 is prime. There's no way we can get them to match up. So to solve one of these, you have to change it into log form. Currently, the variable is in the exponent. So to solve it, we have to change it to log. So we go log. The base to the exponent is 9, so that's the base of my log, of 11 equals y minus 2. Now you go to your calculator. You find out what log base 9 of 11 is. So 1.091 equals y minus 2. To solve for y, we're going to add 2 to the other side. I get y equals 3.091. Try another one. All right, it's the same thing. So let's say I have, let's go, 23 to the 2x plus 1 equals, how about 103? Now we know there's no way, you can tell just by looking at it that we can get these bases the same, right? So we've got to change it into log form. So we're going to go log. The base to my exponent is 23, so that's the base of my log, of 103 equals 2x plus 1. So now we go to our calculator. We find out what log base 23 of 103 is. Thank you. Equals 2x plus 1. Now we got to solve for x, so we're going to subtract both sides by 1, right? Subtract 1, subtract 1. So I have 0.478 equals 2x. And now we divide by 2. Absolutely. And we get x equals 0.239, I think. I'm doing it in my head. So questions on changing those into log. Those make sense? Okay. All right. Next, example number 3 then. We're going to jump down to problems 32 through 38. Here, they start off in log form. So let's say I have log 3x equals -1. We'll do that. Okay, so this is in log form. We have to change it to exponential to solve it. What is the base of my log when nothing's written there? 10. All right, so I'm going to put my little 10 here. So now I'm going to change it into exponential. I have 10 to the exponents over here, -1 equals 3x. 10 to the -1 is 1/10, or 0.1 equals 3x. And we divide both sides by 3. Yep, or we can put it into fraction form. 1 over 30. Or I will take 0.033 if you put it that way. I will take either answer right now. Okay. Let's try another one of these. Okay. Let's say I have let's say I have 4 plus log All right, so 4 plus log, let's go base 10 of 2x plus 3 equals 7. So just like when we were working with absolute values before we can change this, we need to get the log term by itself, right? So in order to get the log term by itself, I have to subtract 4 to the other side. So subtract 4 and subtract 4. So now I have log of 2x plus 3 equals 3. Now that the log is by itself, I can change this into exponential form. My base, remember, is 10. So I have 10 to the third power equals 2x plus 3. 10 to the third is 1,000 equals 2x plus 3. I'm going to go ahead and subtract 3 from both sides. So I have 997 equals 2x. And then I'm going to divide both sides by 2. Yeah, or you can leave it as 997 over 2. Either way, I'm okay with. All right? Okay, where did I lose you? This one? That's your exponent. That's on that side. So you always take the base, which is 10, to the exponent, which is always on that side, is equal to what's behind it. Okay, let's do one more from here. One more. Let's see. How about if I have 3 log x minus 7 equals 12. All right, so is that log term all by itself right now? No. What do you think I have to do? Let's divide both sides by 3. Maybe. So I get log of x minus 7 equals 4. Now to solve this, I have to change it into exponential. Right now I have 10, so 10 to the 4th equals x minus 7. 10 to the 4th is 10,000 equals x minus 7. And we're going to go ahead and add 7 to both sides. So we get x equals 10,000 and 7. So any questions on this so far? So in this section, all of your bases were 10 to make it really easy. It doesn't stay that way, though, so let's try a few more from the next section. So it should be on example number 4, right? Example 4. This is the last section we're going to talk about today. This is 40 through 44. So let's say I have log base 2 of 5 minus log base 2 of 2x equals 4. All right, so first of all, now we got 2 logs going on, right? So we got to condense them into 1 in order to be able to solve this. So in the log world, when we subtract, we really do what? Divide. So I'm going to rewrite this as log base 2 of 5 divided by 2x equals 4. Now I can change this into exponential form. I take my base of 2, raise it to the 4th power, equals 5 over 2x. 2 to the 4th power is 16, equals 5 over 2x. What do I do now to solve? I have to multiply both sides by what? 2x. So if I multiply by 2x, I'm going to get 32x equals 5. And now, divide by 32. We get x equals 5 over 32. Or if you have the decimal, that's fine too. Okay, I want to do one more right here, and then I'm done, and you guys can get started. So I know there's a lot going on tonight. All right, what if we have log base x, or log base 3 of x, we'll do that, plus log base 3 of 7 equals, let's go 15. That sounds good. All right, so first of all, we got to put these together, right? So it's going to become log base 3 of what? 7x, absolutely, 7x. In the log world, when we add, we really multiply. Equals 15. So now, we take our base, raise it to the 15, equals 7x. Then we go to our calculator. We get 3 to the 15th power. 1, 4, 3, 4, 8, 9, 7 equals 7x. And now what do we do? Divide by 7. And x equals? Perfect. 5, 7. I agree. All right, so do we have any questions? I know you guys like solving equations, so this should be good, right? Just remember to get either the exponential or the log by itself before you change it. You guys got this. Again, pay attention to the fact that I skipped over 24 through 30. You do not have to do 24 through 30.